Okay? So I guess yesterday there were some problems with the sound. So this morning they decided to put us on a leash. So we'll see. Okay. So this paper looks at the implications of relative wealth considerations on contracting. Specifically, the starting point is that when you look at a standard principal agent model, when output across firms are correlated, then it's well known that you want to basically compensate your principal relative to the rest, in the sense that if there's a common shock that impacts everybody, you don't want him to be compensated for that. You want him to be compensated only for the part that he's contributing. But when you look at the data, people have had a very hard time finding relative pay performance sensitivity. And if at all, they find the opposite. So that basically the sensitivity to others' output is actually positive instead of negative. So the starting point for our paper is that we're going to provide what we believe is a simple mechanism that's going to show why you get positive pay performance sensitivity. And then that's essentially going to be the starting point. And then we're going to look at a lot of issues related to efficiency. And the basic idea is the following. Let's say you have a manager that cares not only about their own income, but also their income relative to the rest of the other managers. States of the world where this manager is behind everybody else, those are very high marginal utility states. If I'm the principal and I need to contract with this manager and I write the contract ex ante, I need to compensate him for those states. Now, one thing I could try to do, I could basically say, well, I'll just increase his base pay and satisfy the reservation utility. The problem is that that's a very inefficient way of resolving the problem, because when I increase the base pay, I basically increase his salary in all states of the world. Alternatively, I can basically pay him more in states of the world where he's behind everybody else. And by doing that, that's going to shrink the gap, and that's going to be the efficient way for me to compensate the manager. So that's essentially the intuition of what's going to be driving the results. And the mechanism is going to be basically through relative wealth considerations. Now, this is one effect. Of course, you still have the standard signal extraction problem. So you still have some benefit of benchmarking this manager to the other managers. So there's going to be a tension between these two things, and you'll see how this tension plays out and how it impacts efficiency. So when you think about relative wealth considerations, there can be basically two main channels. One is it could be something that's essentially hardwired. So basically people inherently care about their relative wealth or their relative standing relative to other people. And here I have a quick quote. Wealth is any income that is at least $100 more a year than the income of one's wife's sister's husband. Okay? So in this case, it's really hardwired into your preferences. Now, this is not the only way that relative wealth considerations can emerge. Relative wealth considerations can also emerge endogenously when you have competition over scarce resources. So here's another quote. So basically you have two hunters that are being chased by an enraged bear, and will never outrun the bear, screams one of the hunters. I don't have to outrun the bear, retorts the other. I just have to outrun you. Okay, so even though inherently there is no ex-ante relative wealth issues here, once you're in this situation, these things matter a lot. And in fact, in papers that Peter and I wrote with Elon Kremer, this was sort of a mechanism that we sort of highlighted, that this mechanism can help you explain quite a lot of things. So it can help you explain hurting an investment, you can get home bias, you can get financial bubbles, and so on. Now, what do we do in this paper? In this paper, we're going to provide a simple mechanism that's going to provide a resolution for the positive pay performance of others, and in some sense, maybe even more importantly, we're going to understand when this is going to have consequences for efficiency. And as I mentioned earlier, there's this tension. On the one hand, if someone has relative wealth considerations, I want to sort of shrink the gap between him and the others. But there's always in the background this, I want to extract only the part that is relevant to the effort that he's exerted, not to some common shocks. I'll skip sort of the empirical literature, but as I pointed out, it's hard to find evidence for relative pay performance sensitivity. If at all, you have what is called pay for luck. So when others do well, you get compensated. There are a couple of other papers that have proposed mechanisms that will deliver this. There's one paper that I want to briefly touch on, and that's this paper by Euler 2004. In Euler's paper, the effect is coming from changes in the reservation utility. So basically, when other managers do well, his argument is, well, the reservation utility is changing, and as a result, that's going to impact your manager. Now, the two explanations are not mutually exclusive, so you could have both explanations. There is, however, recently some evidence that supports our channel specifically. There's a paper by Duchin, Goldberg, and Sosiora, and what they do is they look at, within conglomerates, look at division managers. And they look at what happens when there's a positive shock to one of the divisions. So when one of the divisions has very high output. And first they show, well, when that division does well, the other division managers get higher pay as well. Now you could argue, well, this has to be, maybe there's some complementarities across divisions. But the punchline, at least from our perspective of that paper, is if you look at these managers, if these managers sit on the same boards, or if they came from the same institution, so they're in the same network, this effect is much stronger. So this peer effect is much stronger when these guys are actually in the same network, and that's going to speak a lot to the theory that we're going to show you today. So basically, we're going to provide this simple explanation. We're going to understand the efficiency consequences. Now we're going to contrast and compare a couple of situations. First, we're going to contrast what happens when you have a single principal with multiple managers. Think of this as a conglomerate. And we're going to contrast that to a situation where you have multiple principal-agent pairs. Now, what is the challenge? In the typical principal-agent model, if I solve for one firm, I know the solution for the whole industry. But now we have this contracting externality. So the contract that I have impacts everybody else's contract. And we need to, of course, this is a fixed point, and we need to solve for this fixed point. Luckily, in the setting that we've chosen, actually everything is very tractable, and everything in the paper itself, you see everything actually comes out in nice closed form. Now, we're going to model relative wealth considerations here as in the utility function. Okay? It's not that we think that this is necessarily the right thing. As I pointed out, it could also be something arising endogenously, but for the purpose of this paper, it gives us a lot of tractability. We're also going to compare what happens when you have disclosure of contracts versus non-disclosure of contracts, and there's some very interesting sort of differences both in the contracts themselves and in the implications for efficiency and welfare. In terms of the setting, in some sense, the basic setting is sort of the standard. So each agent has an output. The agent can impact that output. And of course, there's some random shock. Contracts will be allowed to depend. There's going to be a fixed component. There's going to be a component that's going to depend on your own output. And there's going to be a component that's going to depend on aggregate output, or alternatively, on average output of all the other agents. And in terms of notation, Q minus I, that's just the average of every agent apart for your agent. And there are going to be n plus 1 agents. OK. Now, before we continue with the setup, let's go back a second to the standard benchmark, to the standard case where you have an agency issue and there are no relative wealth considerations. In that setting, it is well known that basically you want to extract the extra that this manager is providing, and the way to do that is to essentially find a signal that best extracts that. And this RPE benchmark is a well-known benchmark. Specifically, we're going to focus a lot on the relative pay performance sensitivity. So we're going to look at the ratio between the sensitivity to pay of others and the sensitivity to pay of your own output. Now, think of this sort of theta and p. For the purpose of the presentation, think of this just as being the correlation. Okay? So essentially, when the correlation is high, this theta is going to be high. Correlation is low, this theta is going to be low. In terms of the maximization, so each agent is going to care not only about their own income, but they're also going to care about the income of everybody else. And the severity of the keeping up with the Joneses incentive, that's going to be picked up by this delta parameter. Okay, so the higher the delta, the more you care about the others. Apart from that, everything here is standard. So we're going to use negative exponential utility, quadratic cost function, and so on. Now you can write this expression, sort of the dependence on others, also slightly differently. You can write it as your income plus something that depends on the difference between your income and everybody else's income. And now you see that this agent basically has an additional risk factor. And this risk factor is how different he is from the rest of the pool.
So you modeled it so it's continuous around the point.
Everything is continuous.
Somebody else passes you.
Everything is continuous, yes. So let's look at sort of the effort channel in this model. The blue line is what happens in the standard model. So in the standard model, my effort impacts my output. That, of course, impacts my income, and that feeds in to my consumption. And think of this sort of C as the adjusted consumption. So this is the consumption after you, quote unquote, pay for the effort that you've exerted. Now here we have an additional channel. My effort impacts my output. Now remember that everybody else's contracts are going to depend on the output of the average apart for them. So when I increase my output, that's going to increase the output that's going to be used as the benchmark for everybody else. That's going to impact their wage. Their wage is something that my agent cares about. So that's going to feed into the average wage of everybody else apart from my agent. And that is basically going to feed back in to the consumption. So this is the added channel that we have in this mechanism once you care about other agents. In terms of the effort choice, well, the benchmark in the case where delta equals 0 is well known. What happens in the case where you have keeping up with the Jones incentives? Well, there are two things. One is you have the incentive to be ahead of everybody else. Remember, you have this risk factor. You want to sort of be ahead of everybody else. That's going to drive your effort higher. And you see that here by the scaling of this 1 minus delta. But you have this additional effect. And the additional effect is when I exert effort, that impacts the benchmark. That benchmark impacts other people's wage. And if I can drive down other people's wage, that's something that's good for this agent. So this is this additional term here, this y minus, which is basically the average pay performance sensitivity to others' outputs of everybody else apart for my agent. Okay? Now, we're going to look at both the situations where I have a single principle and multiple principles. Let's start with a single principle. How's the timeline going to work? Well, quickly, it's basically going to be principal is going to post a contract. Agents are decide whether they accept or reject the contract. Everybody's going to choose an effort level. Outputs are going to realize, and every agent sort of derives utility. The principal is going to maximize expected profits. So basically, they're going to maximize the difference between the total output of all their agents together and the total wages that they have to pay these guys. And of course, they have to satisfy the incentive compatibility constraint in terms of each agent picking the optimal choice given the ability of the agents to determine the effort and each agent willing to participate. So let's look at the results. In all the graphs that I'll show you, on the x-axis is going to be the severity of the keeping up with the Jones incentives. And again, this is basically higher delta means higher keeping up with the Joneses incentives. X is your sensitivity to your own output, Y sensitivity to others' output, and YRPE is what would be your sensitivity to other people's output if there was relative pay performance sensitivity. In some sense, the wedge between the orange line and the green line shows you sort of a dimension of the distortion that is introduced once you have keeping up with the Joneses incentives. On the left-hand side is basically what you have in the benchmark. So in the benchmark case, you have relative pay performance sensitivity. Specifically, the sensitivity to pay of others is negative. But once the keeping up with the Jones incentives is high enough, you see that now the sensitivity to pay of others becomes positive. So when other firms do well, I actually pay my manager more, not less. And this becomes stronger as you increase the keeping up with the Jones incentives. At the same time, the sensitivity to your own output goes down. So essentially, you're shifting between sensitivity to your output to sensitivity to the aggregate. And in the limit, when the keeping up with the Jones incentives is very high, you see that essentially the manager gets compensated based on total output. So you could already anticipate that if you look at, for example, wage correlations, when keeping up with the Joneses are high, correlation across managers is going to be very large. Okay? And one important point is, when do these things switch? Well, they switch when delta is bigger than the RP benchmark. Or in the case when you think of theta as rho, it's essentially this tension between the keeping up with the Joneses, which is captured by delta, and the signal extraction, which is captured by rho. What matters is which one of the two is larger. Once delta is larger than rho, then it's worthwhile for me to actually have positive pay performance sensitivity to others. Now let's look at effort. Effort is actually flat. So even though there's a distortion in the contract, so to an outside-in competition, it seems as if there's potentially some loss of efficiency. In fact, there's no loss of efficiency. Now this result is actually general. So it's not only for constant relative risk aversion, it's going to hold for any utility function, any distribution of shocks, and any effort costs. Now what's the intuition for why the single principal is able to do that? Well, the single principal has the ability to internalize the externality because he basically controls all these agents, so he writes the contracts to all of them. Now the utility of each one of these agents depends on the difference between the agent's wage and all the other agents' wage. And this relative risk part, well, one important thing to note, the average, when I average these things across all agents, and remember that this principle hires all these agents, the average is 0. So given that the average is 0, the principal is able to internalize and hedge this risk completely, maintaining efficiency. Okay? So that's a very sort of stark result. And again, even though to an outsider it might seem that something is off and the incentives are different, in fact you get the same outcome. Now let's look at what happens to wage. Well, as I pointed out, wage correlations, as you increase keeping all the Jones incentives, wage correlations go up. Volatility goes down. Now again, why does volatility go down? Well, remember that as you move towards higher and higher keeping all the Jones incentives, your compensation depends more and more on the total output, on the average. And of course, the volatility of the total is much smaller than the volatility of each one of these agents separately. Now, to someone who looks at this graph without sort of seeing the prior graph, it seems, basically you have here essentially no incentives because at the end, you're perfectly correlated with everybody else. But notice that even though the correlation has gone up a lot, in fact, you maintain efficiency. Okay, so that's an important point. Now let's see what happens when you have multiple principal agent pairs. When you have multiple principal agent pairs, now of course each principal does not internalize the externality. When my agent exerts more effort, there's a negative externality on other agents' utility function because when my agent receives higher wage, that feeds into their utility function and they derive less utility. In terms of the setting is going to be exactly the same. Each principal is going to propose a contract. Each agent is going to decide whether to accept and reject the contract. Now it's important that there's no disclosure of contracts across firms here. So basically each firm writes a contract to its agent. Other firms don't see that contract. Now of course they conjecture what the equilibrium contract is going to be, but they don't actually see the contract. Then agents decide whether to accept or reject the, agents choose effort choice and output is realized. Now let's look at the differences between the case where you have a single principal who's able to internalize the externality and the case where you have multiple principal agent pairs. Now, the leashes. Okay. So there are going to be a couple of things. So first of all, efforts and incentives and sensitivities are going to be distorted upward. And as a result, agents' wages are going to increase. Output is going to be higher. But in fact, in terms of the principles, welfare or sort of profits are actually going to be lower. Now let's compare the two equilibrium. The subscript S is for the single principal equilibrium. The subscript M is for the case where you have multiple principal agent pairs. And you see that the difference between the two is captured by this scaling parameter. Okay? Now, there are two things that are impacting this scaling parameter. First of all, there's the negative externality. When I exert effort, that increases my wage. That feeds back into utility of other agents. So that's a negative externality. And, of course, the principal does not account for that negative externality when they sign the contract with their specific agent. There's a second part, which has to do with the manipulation of others' benchmarks. When I now have higher effort, that also feeds in, and as a result I have higher output, that feeds in to the relative pay performance benchmark that other agents have, and that potentially decreases their wage, which again is good for my agent, because my agent cares about the difference between his wage and everybody else's wage. Now, this Y can of course be positive or negative. When the keeping up with the Jones incentives are small, Y is negative, which is sort of the standard. And in that case, both these effects work in the same direction. So both these effects work in terms of amplifying the sensitivities and amplifying the effort. When Y is large, it becomes positive, and now these effects work in opposite directions. But what we show in the paper is that the net effect is always an amplification. Now, notice that if I look at the ratio between Y to X, well, that ratio hasn't changed relative to the single principal. Even though it hasn't changed, there's a big impact on efficiency. So earlier when I was in the single principal case, I had different incentives, but efficiency was maintained. Now I have the same sensitivities as in the single principal, but the efficiency is very different. So you basically have this decoupling between the sensitivities and the efficiency. In terms of the effort incentives, well, again, the left-hand side is the case where there are no keeping up with the Jones incentives, so this is sort of the single principle. And as you see, the more severe the keeping up with the Jones incentives, the higher the effort. And in some sense, this is a bit different than what you see in most principal agent problems, where typically underinvestment is the problem. Here you actually get overinvestment. In fact, you can get even overinvestment above the first best. So it can be very, very severe. In terms of wages and output, as I pointed out, wages are going to be very high. So you're going to have very high sensitivities. Average wages are going to be very high. Productivity is going to be very high. But profitability is actually going to be low. So this is going to hurt profitability. Now, up till now, we looked at one channel where sort of efficiency can be harmed. There's another channel, and that has to do with the ability of the principal to commit to the contract that they provide the agent. Now, the principal may potentially not be able to fully commit, in which case he can privately renegotiate. To see this channel, let's go back to the single principal case. So I have a single principal who's hiring multiple agents. Well, that single principal can come to one of these agents and privately negotiate. Now, what incentives does he have when he does that? Well, first of all, there's exactly what we had in the multiple principal agent case. Okay? So now there's a negative externality part, because when I renegotiate, I'm not accounting for the impact on utility of others. And there's the manipulation of the benchmark performance, just like you had with many principals, because also with the many principals, they didn't see each other's contracts. But there's an additional channel here. And that additional channel is, well, because this principal manages all these agents, when I can make one agent better, but if that drives everybody else's wage down, I save money. So that's sort of an additional constraint. Now, of course, in equilibrium, all the principals understand that you can do this. But this off-equilibrium sort of threat is going to impact the contract. Specifically, you see that relative to the single principal, there are these two components. One component, which I talked about earlier in the multiple principal case, that's exactly the same effect. The second is what happens as a result of internalizing the impact on the salaries, which reduces the wage bill wage bill for the principal. Now this, of course, can depend on whether you're in the region where keeping up with the Jones incentives are small, so Y is negative, or in the region where keeping up with the Jones incentives are high, and Y is positive. Now what you can see is that and what we can show is that these two together, that they're always sort of, the sum of these two is always a positive number. So as a result, the sum, I guess, of this with the minus is always a negative number. Okay? So as a result of that, you see that relative to the single principal, when the principal when the principal has the ability to renegotiate, you're going to have an amplification of the incentives, and that's going to impact wages, and it's also going to impact profitability and welfare. So the welfare is going to be lower for the principal, and it makes sense because in some sense you're adding an additional constraint in the optimization problem. Now relative to the multiple principles, this can go both ways, and this will depend on how severe the keeping up with the Jones incentives are. So if you're in the region where keeping up with the Jones incentives are small, Y is going to be negative, and you're going to be above the multiple principal case. And if you're in the region where they're high, you're going to be below the multiple principal case. Now, up till now, contracts across firms were private. We're going to look at what happens now when contracts across firms are also externally disclosed. And in 2006, for example, there was a change in the SEC that now firms need to disclose a lot more information about the compensation contract of their managers. So the setting is going to be very similar but slightly different. So again, each principal is going to propose a contract to its agent. Agents are going to decide to accept or reject. All contracts are going to be disclosed, so now everybody knows what other agents' effort levels are going to be given the contract. Agents are going to choose the effort level, and output is going to be realized. So what happens in this case? So the first thing is, because you see everything, you get this amplification in sensitivities. So relative pay performance sensitivity goes up relative to the case where you don't have disclosure. And in fact, the sensitivity to others' output can actually be higher than the sensitivity to your own output. Now that does not happen when contracts are not disclosed. But once contracts are disclosed, that sensitivity is higher. Now as a result of that, that's going to have an important impact on incentives. So let's look at the difference in incentives. Again, the blue line is what we had when there was no disclosure. Now we're looking at the case with external disclosure. When keeping up with Jones incentives are small, the effect is similar to the no disclosure, but slightly less. More importantly, once you get to the region where the sensitivity to performance of others is very high, now you have an incentive to do the following. I know everybody else's output is positively related to my output. I'll actually reduce my output. If I reduce my output, yes, it's going to hurt me through the direct channel, but it's going to decrease everybody else's wage a lot, and in terms of utility, that's something that I'll like. And as a result, you see that with external disclosure, you can actually now have underinvestment as opposed to overinvestment. Okay, so to briefly conclude, we introduce here what we believe is a simple mechanism to rationalize pay for luck. In the single principal case, you're going to get distortions to the sensitivities of the contracts, but efficiency is actually maintained. So to an outside competition, it might seem as if there's loss in efficiency, but the principal is able to fully internalize the impact of the contract and maintain the same level of effort. With multiple principals, well, now you have the externality. As a result of that, incentives are going to be higher. You're going to have higher productivity. You're going to have higher output. But the profits to the principals are going to be lower. In the case of looking at commitment, if you have a single principal, the inability to commit is going to lead to higher powered incentives and lower profits. Now, one last point. In the paper, we also look at the case where you have multiple principals, where each principal hires multiple agents. And what we show that when you have multiple agents, the lack of commitment, the lack of ability to commit basically leads to a situation where when keeping up with the Jones incentives is small, it's more efficient and welfare is higher if you have commitment, but when keeping up with Jones incentives is high, it's actually better to the principals when there is no disclosure. Okay? And my time